Hello. I hope you are doing well. I am doing great. Thanks for asking. Today, I was bored and I was like, let's implement the bubble sort algorithm in R. So, if you have never heard of bubble sort, it's one of the worst performing sorting algorithms out there. So, we are just doing this for the love of the game, nothing more. Okay, so I'll first take you through the manual way of doing bubble sort and then we'll write the algorithm in R. So let's start. Let's say you are given this vector and you're required to sort it in increasing order, right? So the vector has, it's a numeric vector, of course, and it has the elements 50, 15, 20, 30, and 5. So what bubble sort does is it says I am going to go through the values in this vector and I will check, I'll be comparing two values at a time. And basically the values being compared are the adjacent values. So at first it's going to compare 50 and 15. And the question it's asking is 50 greater than 15? In this case, it's going to say yes. So it will swap the values, right? So you get the concept. And then it's going to move on to now 50 and 20. And then it's going to swap the values. So let's do the manual implementation. So we are going to start with 50. We have 15. We have 20. We have 30. And finally 5. This is our starting point. So I'll start from the first index, right? So this is the first index and I'll be comparing the value in the first index with the value in the second index. So I'm asking, is 50 greater than 15? And I'm like, yes. So that means we need to swap these two. So 50 goes to position 2, 15 comes to position 1, and then we still have the rest. Okay, let's now move on to index 2. So this is where we are. So remember, after the swap, this becomes our new vector. So we are now at index 2 and we are asking, is 50 greater than 20? Yes. So again, we need to perform the swap. So we take 50 there and bring 20 here. So our new vector becomes 20, 50, and then we have 30, we have 5 at the end, and at the very start, we have 15, right? Okay, now let's move on to the third index. So this is where we are, and we are asking, is 50 greater than 30? You see, the same question over and over again. Okay, so in this case, we still need to do the swapping. So we have 30 here now as our, in our new vector. So 30 is here. We have 15 in the fourth position. We have 5 at the end. Then at the start, we have 15 and 20. Okay, then we are going to go to the fourth index. So this is where we are. And we are asking, is 50 greater than 5? Yes. So we do the swapping thing. So now, on the fourth position, we have 5. At the very end, we have 50. And then we have the rest. So we have 15, 20. Then we have 30 there. And that's our new vector. But then we can't go to index 5 because we'll be comparing index 5 and index 6. And that will be out of bounds. So that means with bubble sort, we need to go up to the fourth index, or rather n-1 index, because we can't compare n and n+1. Does that make sense? Assuming n is the length of the vector. So with bubble sort, we need to go up to n-1, and we are assuming that this n is the length of the given vector. Okay, so now, not one thing, this all this work we have done here, this is the first iteration. And our array, or rather our numeric vector, is not yet sorted. So after the first iteration, bubble sort says it's not yet sorted. Let me go through it again. So we start again, and this time we are starting with our newest version. So we are starting with 15, 20, 30, 5, and 50. So bear with me. I just have to do this so that I can show you some concept. So let's start with the first position, the first index. This is 15. So we are comparing 15 and 20. Do we need to make a swap? No. So nothing happens for that first index. We move on to index number 2. Here we are comparing 20 and 30. Do we need to swap? No. So again, nothing happens for that second index. Now let's move on to index number 3. Now we are comparing 30 and 5. Do we need to make a swap? Yes, because 30 is greater than 5. So we swap these two, and by the way, that was the third index. Let me write. So once we swap, we have 5, then we have 30. At the very end, we have 50. And then of course, at the start, we have 15 and 20. Right? So now that was the third index. We still do for the fourth index. So for the fourth index, we are comparing 30 and 50. And we're asking, is 30 greater than 50? No. So we do not need to make a swap. Remember, we are going up to index number 4. So at this point, we do not need to go further. So this becomes our second iteration. So this is the second iteration. Bubble sort says, we are not yet done. So let's go for another iteration. So in the new iteration, we are starting with 15, 20, 5, 30, and 50. We start again at index 1. We are comparing 15 and 20. We do not need to swap. So nothing happens for index 1. We go to index 2. For index 2, we are comparing 20 and 5. We need to swap because 20 is greater than 5. So we swap these two. So now our new vector becomes 5, 20, 30, 50. And at the start, we have 15. Okay. So now that was we did that for the second index. So now we still have to go to the third index. So this is where we are. We are comparing 20 and 30. Do we need to make a swap? No. So nothing happens for that. Then we go to the fourth index and we are comparing 30 and 50. Do we need to make a swap? No. Okay. So this is the third iteration. Okay. So bubble sort is like, are we done yet? No. So we need to make another iteration. Okay. So in the new iteration, we are starting with 15, 5, 20, 30, 50, right? So we go to the first index, and this time we are comparing 15 and 5. Do we need to make a swap? Yes, because 15 is greater than 5. So we swap those two, and our new vector becomes 5, 15, we have 20, 30, and then we have 50. So this is our new vector. And then we still, once we start going through that array, we can't stop. I mean, the numeric vector, we can't stop. So we still have to check for index 2. Then for index 2, we are of course comparing 15 and 20. Nothing happens. We go to index 3, comparing 20 and 30. We don't need to swap. We go to index 4, and we are comparing 30 and 50. Again, no need to swap. Okay. So now let's talk about like these repeated checks. And the thing I want you to note is, let's start with the first iteration. And I want you to note, once we go from index 1 to the last index of that array, at the end of the day, we will have pushed, actually let me change the color for this. We will have pushed the largest value in that array to the very end. In this case, the 50. So by the end of this first iteration, we have pushed 50 to the very end in its rightful position. Let's check the second iteration. In this second iteration, the same thing. We have pushed the second largest value to its rightful position to the right. And let's check the third iteration. We have also pushed 20 to its rightful position. So what we need to tell BubbleSort as an optimization strategy is, after each iteration, right? So we are saying, once you make the first iteration, the next time I don't want you to go all the way to like 4. I want you to go to 3, right? And then for the one after that, I will want you to go only up to 2. And then finally, I will only want you to do the first index. So you see, we have kind of reduced the redundant checks. Okay, so that is it. And then what else do I want to say about this algorithm before the implementation? I think that's it. You can see it's pretty repetitive, redundant. So yeah, let's implement this. So I'm just going to switch to R, well, my terminal, and let me move over to my keyboard. So we want to implement this function called BubbleSort. Let's have a bit of function documentation here. So we are saying this function, BubbleSort, or rather I could have said the BubbleSort algorithm, and it's going to be taking one parameter, so at parameter x, and you are saying this parameter, it's going to be a numeric vector, and it's going to be a required it's going to be a required parameter, and it's going to be the vector to sort. So the vector to sort, and then what is going to be the return value of our function? So it's going to return x sorted in increasing order. And if this were in a package, we would like to export it, right? By the way, is there like a package which implements these algorithms in R? Would be fun. I don't know. Anyway, so we've said that our function is going to be taking a parameter x, and of course we want it to return that x, and let's make a for loop for the first iteration through the vector. So we are saying for index in, let's go with sequence along. So for index in sequence along x, what do I want to do? So I want to compare. So we are saying if x subset index is greater than x subset index plus 1. So basically just comparing adjacent values. So we are saying if the current value is greater than the next value, then I want you to swap those two. And to swap, let's just have a temporary variable here. So temp is going to be the current value, and then we are saying the next value, index plus 1, is going to be temp, which is the current value. And then am I getting this right? So we have temp is the current value, and we are saying the next index is going to be temp. No, this should be, I should do it the other way around. Let me just do, yeah. Let's do x subset we change the current value since we have already held it in a temporary variable. So we are saying the current value is going to be the next value. It's going to be index plus 1, and then we are saying the next value now at index plus 1 is going to be temp. So we've basically like swapped those two values. Okay, then what are we saying? Actually, that's all we are saying in the for loop. So we are saying, so long as you go through this once, if the current index is greater than the next index, then I want you to swap those two values. But remember, we can't go all the way to like the last value of x. We need to go to the length of x minus 1. So let's change this, and we are going to have it as sequence length, and the length out will be the length of x minus 1. So this is like a single iteration, right? So let's actually run and see what we have after a single iteration. So we are just going to do our script bubble sort, and you see after a single iteration we have already pushed that 50 to the very end. Okay, but then we don't want to do just a single iteration. We want to iterate until the vector is sorted. So what we have to do now, let's wrap this for loop in a while loop. So we are just going to say while true. I mean, we really need to iterate through this until it's sorted, right? So while true, I want you to do this iteration. But then how are we going to exit the while loop, right? So let's have a variable here, and we are going to check if we have done any swapping through that iteration. So because the idea is, if we are going through the vector index 1, index 2, index 3, and we have made a swap, then the array the numeric vector is probably not yet sorted. So we go through another iteration. But if we have gone through index 1 all the way to the last index and we have done no swapping, it means that it is sorted. That is when we should exit the while loop. So in this case, we are saying by default, let's set swapped to false, right? And then after swapping, we are setting swapped to true, since yes, we have done the swapping. And then now, once we do one iteration, index 1 all the way to index 4 in our case, we should check, did we swap? So we are saying if we did not swap, I just want you to return x, and that's literally it. So like, does that make sense? So we are saying once we go from index 1 to the last index, we check, did we do any swapping? If we didn't do any swapping in that iteration, it means we are done. So we should exit from the while loop and return from the function. And that's basically it. Let's run this. So our script bubble sort, and there we go. So now we have 5, 15, 20, 30, and 50. But remember something, we said that after each iteration, I do not have to go to the end of the vector. I need to go to the last index I went to minus 1. Like if for a start, we are going all the way to index 4. In my next iteration, I should go to all the way to index 3, 2, 1, right? You get the point. So this means we can, have a small optimization here, and we are going to say the max index by default, it's going to be the length of x minus 1. So we replace this length of x here, minus 1, using the max index. So, and we are saying after each iteration, if we have not yet returned, we are going to take that max index and we are going to reduce it by 1. And that's it. So this is just, a small optimization. Let's confirm that this works. And yes, there we go. It still works. So that is the implementation I have for bubble sort in R, and I hope you took something out of this video. Have a great day.